Welcome to the R course on and a lecture on data wrangling. We'll be working with a bunch of different tools today on wrangling data. I'm Cory Whitney, and you can contact me via email. So I'm going to talk about tidyr and give you some notes on tidyr. This in the tidyverse, you'll see the URL there, but check it out in the tidyverse. First of all, just to make sure we're all on the same page, I want you to check your R version. So you can do that just by typing version into your console. So I'm just going to do that here. Check the R version, and type here. Whoops, check. I'll leave this here with, and I'll just type down here, version. It'll tell me what version of R I'm running. I have version here in version string. I have version 3.6.3 holding the windsock. Here I can either click on run, or I'm using a Mac, so I can do command return, and it will run that line of code. And you can see I get the version of R. So check with version to make sure we're all on the same page. The easiest way to get all of the libraries for this section now is to install the whole tidyverse. So go ahead and type library tidyverse. And if you've installed it already, then it should run just fine. You'll have it installed. If you haven't, of course, then we need to use a function called install.packages. You see it comes up here for me. I can just hit enter on my machine, and then I put quotes around tidyverse. But if you run that line of code, it'll install the package, and I recommend also putting a hashtag there so that this doesn't run when you try to run this script in the future. You can also learn more about a package that you're interfacing with by using the browse vignettes function. Our vignettes, here we go. So some vignettes have showed up, and there they are in your, so that should open automatically in your web browser. Now I'm going to go back to full screen. Good process for keeping tidy data is that, of course, when you're programming, you want to import your data. You want to keep your data tidy. So you want to tidy it up, clean it up, get it ready to work, and then you can start understanding your data. You can transform, visualize, and model, and finally you can communicate in the form of your papers or PhD. It's really critical that we do really good punctuation in our coding. So good coding style is like correct punctuation. Without it, things are hard to read. The machines that we're working with, they really need very clear communication. So if we write it wrong, we are going to hit errors, and we'll talk about errors later and how to deal with those. But the most common error is human error. That is poor punctuation, poor spelling, things like this. So we want you to keep your data tidy by following just a few simple rules. First of all, when your data is tidy, each column is a variable, each row is an observation. This consistent structure, it allows us to focus on our work, on understanding, instead of trying to figure out the structure of the data set. Each variable has its own column, each observation has its own row, and each value has its own cell. So we're going to transform, we're going to learn how to transform things, and that is really the first step when you have tidy data, and it's a way for narrowing in on observations. What we're going to do is create new variables that are functions of existing variables. We're going to learn how to do all these things now. So we're going to be using dplyr, as we said. That again is Hadley Wickham. Do read more about him. In a dplyr is based on sets of verbs, and every argument in a function, when you use one of these verbs, verb names, the arguments always start with the name of your data frame. We're going to use a few. There are many, and I recommend that you look into them and try to understand and see how these could be useful for you. So select, these are the ones I use most commonly. Select returns a subset of columns. Filter extracts a subset of rows. Arrange reorders the rows. Rename to rename the variables. Mutate adds new variables and columns. And group by can split the data into groups. And finally, summarize can generate tables of summary of the data. We're going to try all those. And I recommend looking at Roger Peng's stuff. For example, he puts everything on GitHub as well. It's open access. So first thing I want to do is create a new object, and I want to call it ACA work filter, academic work filter. So I'm going to use select, the verb from dplyr. I'm going to say participants data is read CSV participants, and then I can tab over. Some people do this. I can go into data wrangling, or I can just go straight here. Participants data CSV. Okay. This again is why filing is so important. File structure is really important when you're working with any programming tools, but the filing structure is really critical, that you have everything within this project. The R project file is within a project, and the project is where everything is stored. So the data set is not somewhere on my desktop. It's not on a hard drive. It's not located in some weird place. In our particular case, I put the data really right into the project, and that's ideally how it will work. I know some of you will have really large data sets, and we'll have to figure out ways to integrate here. But generally, you've got a data set which is in a manageable format. It's tidy, and you can put it right in the same project folder. Everything is within the same project folder. So I'm going to assign participants data by read CSV. Again, just use question mark read CSV if you want to know what that function does. And you will get a help file that shows you that it's from utils. So it's a base package. It comes with R automatically, and it reads, here it is, it reads CSV is the first one. The first argument is the file, so it just wants to know what is the file. And then it will import it. So now I have an object, participants data. It's in my environment. Some people like to interact with stuff up here. I don't that much, but participants data is there. 19 observations of 17 variables. And there are the variables. I can also call str for structure, participants data. There it should show up, and then I can call that, and I get the same sort of information. I guess a lot of people like to use this environment. You may get comfortable with that. I like command line, so I can just use that str, put it in my notes here, participants data. Academic work filter, we're going to run the select function. Again, that's something you can learn more about by asking the help file. What is select? It's part of the dplyr package, and it renames variables. So what we're doing is saying the first argument, as we said, is the data set, and the next arguments are the variables. This academic work filter object is, you can see it shows up here in my environment, and I can call names, for example. Find out that it has two names, there are two columns, and these are academic parents and working hours per day. I can also write that here, names, ACA work filter. And I can also call head command return on a Mac, or you can hit run up here to run that, and then you can see just the first 6 rows and academic parents, working hours per day variables. So we've created our academic work filter. Using the select function, we're going to use the select function to create a non-academic work filter here. We just add, to try this out, we just add a minus here, a subtraction symbol in front of the variables, and then we have a data set that is without academic parents or working hours per day, but maintains all the other variables. So I'm going to go non per day. When you run this, it should work. And I can see that non-active work filter if I call, again, names. Then I can see that the non-active work filter does not include academic parents or working hours per day. It's a filter, it's an object of filtered observations to select rows that meet certain criteria. So I'm going to use that filter function. I'm going to create a work filter and use the function filter from dplyr, the observations. I'm going to use filter to do even more fine selection. So all of those who work more than 10 hours a day and have a name, a first name, which is more than 6 letters. Okay, so I'm going to go work name filter, creating a work. And now I've got work name filter. And you can see there's just one. And it's from 2007, someone from 2017, who shall remain anonymous. We're going to assign participants data, rename this thing because I think letters and first name is quite long. It's hard to remember, so I'll just call it name length. So I use, for rename function, you use the old name and replace it with, you use the old name as the second argument, you replace it with this new name. So new name and the old name you'd like to replace. So we're going to use the rename function to change a name. We give a new name for an old name. Daily labor is working hours per day. Let's do that. So again, participants data. That was too long, that variable name, so I'm giving it a new name. So now participants data, if I run both of these, run and run, now participants data. If I try to run it again, actually working hours per day has been replaced with daily labor. It no longer exists. So now if I open participants data, let's just get names again, ask for the names. You can see working hours per day is no longer there. And now we just have daily labor instead. Now let's use the mutate function. Mutate creates the new variable. So again, I'm giving this new variable name, and it is the result of something in the next argument, which is I want to take daily labor times the mean of daily labor. I want to get a labor mean. So I'm going to go daily labor times the mean of daily labor. That's some issues here. Participants data. Daily labor. Now it shall have a new variable, and that variable, we can call that variable here by using the dollar symbol. Use that dollar symbol to call a single column or single variable within a data frame. And you can get labor mean, you get a list here of labor mean. Let's run that. Now we're going to use dplyr mutate to create a commute category. So the way I do that is to link the base R if-else function with the mutate function. This is cool because you can write lots of if-else arguments. We're just going to write one. So we're going to say mutate participants' data, and the commute is the new variable, which will be the product of if kilometers home to Zeph is greater than 10, we'll call them a commuter, and otherwise we'll call them a local. This will be a factor. So we're going to group data by commuters and non-commuters using the group by function. So this is from dplyr group by. First argument is data, participants' data, and then we'll group by commute. Then the next thing I'm going to do is create a commuter summary. So I'm going to summarize the commuter data. And I'm going to summarize it according to the mean of the days it took you to respond to my email and the median of your name length. But I can perform all of those tasks using a pipeline. Pipeline is from the Magrider package. It's also included in the tidyverse. And the pipeline is just this argument. And what it does is it passes the data set onto a function. So this is the function here, our mutate, to create a commuter, to create this commute category. And what we're going to do, what it does is it just takes that first argument. You can see here for mutate, there is no first argument of a data set because the Magrider tells this that the first argument is to use this data set. The benefit here is that after I've produced the result of this mutate function, whereas before we had to assign that to a new object, it will assume here that the result of this operation should be the data set for the next thing, which is group by. So it's going to group by, and it has that commute variable in the data set, even though that's not in participants' data. It becomes part of the new data set after we mutate. And then we're going to summarize based on the commute, the mean days to email response, the median name length, the maximum years of study. And I'm just going to run here as data frame as the last argument so that we can get the output not as a tibble, which is usually the output of these tidyverse functions, but instead as a data frame. And then we run that. For those who followed very closely, that should have been, so when I made name length, that should have been participants' data. You caught that while you were programming. Now we can see pipe data is a data set with days to email response. So for the afternoon, what I would encourage you to do is to work on your own processes, maybe even some of the stuff we've done today, and try to work that into a pipeline. I haven't put all of the functions into a pipeline. We're assigning lots of objects and then performing more operations. So try that with Magrider. And do all of your own queries, so maybe on your own data sets or making different queries of this particular data set. Try to learn some more stuff from that. As a bonus, I'm going to show you this tool called Purr, also from the tidyverse. This library Purr has a cheat sheet. Check that out. And you know how to browse vignettes and do things like this, so find out about Purr. Here are some more resources for Purr. Visit on the tidyverse. Also check out Variants Explained, where you get some good ideas about how to do that. The first thing we're going to do is to try, the only thing actually we're going to do is to try running Purr to get the R-squared of some silly regression model. But here, yeah, so library Purr, using it, we need to, of course, first to load the library. If that doesn't work, it means you need to install the package. We're going to perform this regression by taking your data and splitting from I can put a note here for myself. This is from base R, so we're going to split just like mean and other things. Because it's from base R, we're going to use that $sign as the operator. This refers to the data set. We're going to say split at batch. That's the year that you came into Ceph, of course. And we're going to map these to a regression model. LM refers to a model. Days to email response, daily labor again, and this is the data for the LM is referred to. This just refers to participants' data. And we're going to map a summary, and we're going to ask for the R-squared from that regression. So it's basically a perfect fit. So apparently it explains it too well. There may be something wrong with the model. I'll give you another example with use the MT cars data. So there's a lot of different data sets that are built in. Is a data set, you'll see over here in the help file. So I just put !MT cars. And it just tells me about the data set. So check that out. And then I'll show you an example with cars. Regression. I'm going to create a new regression, a new object, which is a regression. And it's going to be based on this MT cars data. Just a bunch of data about cars. And now I can run that. It's essentially the same regression formula. I can run that and again get some idea. This is the cylinders, right? Because I've split it up by cylinders, and now I get an R-squared for each of these. So for the afternoon, try doing data transformation either on this data set or your own. Use the Magritte pipeline to simplify a series of tasks. Use the tools that we talked about to mutate, to do all these things, and run summary statistics. I'm going to also invite you to look at the data set. So we looked at MT cars, try diamonds, iris, maybe ethnobotany data. Do long formats in base and then short formats, or long formats in normal code and then shorter formats with the Magritte pipelines. Run some descriptive statistics on these things with base and dplyr, and I invite you also to run things with the Purr library. Now, one of the things that you may have noticed in the latest code writing is that I haven't really given myself a lot of notes here about what's going on. This is to show you, I'm providing a bad example so that you can see later that it might be really hard to look at this and try to figure out what happened. So what I would recommend that you do is to not only provide notes for yourself, right? I'm going to load the data, right? That's what I'm doing, but I may even want to put those 4 hashtags here so that I can find that later. It's up here in my collection, right? You want to do that for all of your steps that you've done here. That's it for today. Those are the tasks, advanced and simple tasks for the afternoon. Please share with us the results of your work and ask your colleagues and us for help or for feedback. Thanks very much.